Hello, everybody. I'm going to go over the seasons notes with you. This is Unit 5, the Seasons Interactive Notebook. All right, reflect on the essential questions before you dive in. If you were quizzed today, which questions would you know the answers to already? So, what causes day and night, and what causes the seasons to change? I'm looking to see which answers you could answer. If you cannot answer either one of them, that's fine. Just say none. For number 2, which question would you need to learn more about to answer confidently? Um, Again, if you do not sure because you need to learn both of them, then you need to say both and go from there. All right, the seasons. Before you begin, let's see what you already know. On the next 2 slides, you will be asked some questions about the movement of Earth. Try your best to fill in what you can. As you go through the presentation, you can go back and add to you or adjust your answers. All right, 4 of these descriptions relate to Earth's revolution. Click on and drag the descriptions to the 4 Earth positions in the diagram. So again, we're going to be looking at the revolution. So describe revolution in your own words using the circles you placed as a guide. So revolution means to go all the way around the sun. Or revolution means to go around something. So when one object goes around something. So in the end, we're going to be doing the movement of one object around another. So you click on it and you drag it. And it does not matter where these go. The next one says the action of spinning on an axis. So does that mean going all the way around? No. Earth orbits the sun. Orbit is the path the Earth takes to go around the sun. So in this case, yes, Earth orbits the sun would go over into here. All right. So we know that Earth, the action of spinning is not the answer. So we're going to cross that one off. The Earth is at a constant tilt of 23.5 degrees. So revolution, as the Earth is going around the sun, it is always tilted at 23.5 degrees. So yes, that is an answer. Causes day and night or night and day. So as Earth goes all the way around, is that why we have night and day? No, this is not why we have night and day. Okay, and then finally, 1 year equals 365 and a fourth days, or 365.25 days. Yes, this is true because it takes Earth 365 and a quarter days to get all the way around the sun. All right, next. So you should be dragging. The Earth is at a constant tilt, and 1 year equals 365 and a quarter days over. All right. When you have the revolution and the tilt of the Earth, you get the seasons. Oops. All right, slide number 5. All right, now we are going to talk about rotation. Rotation is when Earth spins on its axis. The axis is this imaginary line that goes from the North Pole to the South Pole, and Earth spins counterclockwise around this. So spinning action. So is the movement of one object around another spinning? The answer is no. So no. The action of spinning on axis? Yes. 1 Earth day equals 24 hours. So as Earth spins around the axis, it takes us 24 hours. So yes, the Earth is at a constant tilt of 23.5 degrees. Okay, we're going to come back to that one. Causes night and day? Yes. And then example, Ferris wheel or pinwheel. So for rotation, you will choose 5 of them, it says. So you're going to use all 5 of them. So the only one that does not fit in here is the movement of one object around another. So a Ferris wheel or pinwheel is something that spins. So again, rotation. Okay, Earth is always tilted at 23.5 degrees. Remember that? So 23.5. Sorry, I'm writing with my mouse. 5 degrees is the tilt. All right, so we are going to drag over these items. The fifth circle, you can put on this Earth, but I'm going to put it next to it because I want you guys to notice that the spin goes around. All right, describe rotation in your own words using the circles as above as a guide. So what does rotation mean in your own words? You can use any of the items in the circles. So rotation means Earth spinning on its axis. Oops, Earth spinning its axis, causing day and night. And again, this takes 24 hours. All right, slide number 6. Southern hemisphere. So the southern hemisphere would be at the top of our Earth. So I'm sorry, northern. So northern hemisphere is at the top. So northern, 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 northern. So during the summer northern hemisphere, the northern hemisphere is tilted towards the sun, as you see here. This is going towards the sun. Most direct sunlight, so we have the most direct sunlight, longer days and shorter nights, and the North Pole has constant daylight. So constant daylight in the North Pole. Why? Because um, the top northern part is getting the most of the sun rays spread out. So spread out across. So we're going to have constant day. So it's going to constantly be light in the North Pole. All right. Is the northern hemisphere tilted toward or away from the sun during summer? So is it tilted towards or away from the sun? So again, we're going to look at the northern hemisphere. Is the northern hemisphere tilted to the sun or is it tilted away from the sun? So as you can see, it's tilted more towards the sun. So your answer here would be towards. Oops, sorry, go back. All right, slide number 7. Fall, northern hemisphere. So again, we're looking at the northern hemisphere, which is the top part. The fall, also known as autumn, the axis is not pointed towards nor away from the sun. So again, it's saying that because this is tilted all the way to the sun, but as you get to the fall, it's not. So if you look here, it is not tilted to the sun. It's not tilted away from the sun either. So it is basically straight up and down on that day according to the way it goes around. So equal sunlight in both hemispheres, equal length days and nights at the equator. So the equator is that imaginary line that divides the northern hemisphere from the southern hemisphere. And during the fall equinox, also known as the fall, the Earth will be equal days and nights at the equator. So we are going to have equal day and night at the equator. All right, slide number 8. Winter, northern hemisphere. The northern hemisphere is tilted away from the sun. So look at here, the northern hemisphere is tilted away from the sun. Most indirect sunlight, which means it's scattered. Shorter days and longer nights. And the South Pole has constant daylight. So instead of the North Pole, now the South Pole because it's going towards the sun. Now, what is going to happen in the North Pole, during the winter? So think about it. Look how much sunlight it is getting. It's getting none. So during that time of year, it's going to be constantly dark in the North Pole area. All right, so is the northern hemisphere tilted towards or away from the sun during winter? It is tilted away. All right, slide number 8, which we just did, and then slide number 9. Spring, northern hemisphere. The axis is not pointed towards nor away. So again, we're looking at the northern. Again, it's not tilted towards the sun. It's actually coming back towards the sun, but in this case, it's not tilted towards the sun. So if we follow this, it's not tilted towards the sun. And it's also not tilted away from the sun. Equal sunlight in both hemispheres, and then equal length days, 12 hours and 12 nights at the equator. Again, the equator is that imaginary line. Oops, I'm sorry, should not be doing it there. The imaginary line that divides the northern hemisphere from the southern hemisphere. And this is spring. All right, think about it. During summer in the northern hemisphere, the sun appears smaller than at any other time of the year. This is also the hottest part of the year. Use your knowledge of seasons to explain this phenomenon. Hint, which way is the Earth's axis pointed in summer? What does that mean? So our hints are the Earth's axis is pointed in the summer, so what way? And then what does that mean? So again, it is the hottest part of the year because summer in the northern hemisphere, and let's go back to the summer slide, receives the most direct sunlight. So that's going to be a key. So the most direct sunlight. Due to the tilt, of the Earth, the elliptical orbit, or the path that the Earth takes, the northern hemisphere is actually farther away from the sun in the summer. So because Earth is going to start taking this elliptical path, and again, it's not a complete circle, it's an oval. So as it comes around, it's going to end up being farther away from the sun. Therefore, Therefore, the sun appears to be smaller. So why does the sun appear to be smaller? It is due to the tilt and elliptical. Remember, elliptical means oval or an ellipse. So not a perfect circle path or orbit. And orbit means the path. Elliptical orbit of Earth. Oops, not Earth. The northern hemisphere is actually farther away. Farther away from the sun. The summer. All right. And actually, a fun fact, hopefully you guys are starting to catch on that the summer, on the first day of summer, which is June 21st, the days are actually, it's the longest day of the year. However, starting on June 22nd, the days start getting shorter and shorter because Earth is going, the Earth is starting to go away from the sun because on the first day of summer, and then from there, we're going to start getting less and less daylight. All right, we're going to stop here for now.